Okay, we're going to be working on the word problems from Chapter 8, and we're going to be focusing on 8.1.8.2 today, and then we will continue on. And so when I think about doing word problems that involve a quadratic function, there is a graph involved. We want to remind ourselves of the two graphs, one of them being that when it opens down, that we know that the leading coefficient is positive. That means that my model that we're looking at is always going to be ax squared plus bx plus c, and this actually should be equal f of x or y, either way. So that's going to be our mathematical model. So I know that if it opens down, it's a U-shaped graph that opens down, that in essence I know that it's got a vertex. The vertex we labeled as h comma k. And also, if it opens down, it's got a maximum. So that anytime you're dealing with a quadratic model and the word maximum or minimum is mentioned, you're looking for the vertex. So anytime you're reading a word problem and you know that the model is quadratic, then you say to yourself, quadratic, if it says maximum or minimum, you know you have to find the vertex. And remember that this is the good old axis of symmetry. Put this in because even though we don't use it, it's x equal the x coordinate of the vertex. It would be x equal h. So it's the x coordinate of the vertex. So you need that for graphing more than you need it for anything else. If this guy opens up, we know that A is positive.
Oh, you did the other one opposite. You put A positive on that side.
Oh, I'm sorry. That's because I'm used to having it that way. That's the order in which I tend to do things. And of course, white tape. We'll fix it like it never happened. I said negative and then didn't do it. I usually do the positive one first, then the negative, but that's what gets me into trouble. We know that A is positive. That also means that, again, he has a vertex. And since he opens up, it is a minimum. I can't spell minimum today. Now remember, the vertex is h comma k, and the minimum is y equal k, as well as the maximum would be y equal k. You can say it is at some x value. But when you're looking for a minimum and maximum in a word problem, it's going to be the y value. It's going to be the y value. And of course, this is the axis of symmetry, and it's always x equal h. So if you've got a mathematical model that's ax squared plus bx plus c, basically if it says maximum or minimum, you replace that word with vertex. That's how you know what you're finding. So in 8.1, this is one of the word problems from 8.1, and it says the volume of a box with a square bottom and a height of 4 inches is given by, and that's when we say, woohoo, they gave me the formula, where x is the length in inches, now we know what our units are, of the sides and the bottom of the box. So the box has a square bottom. We're told that not necessarily that the top is square. So, I mean that the height is the same as the top. Now the units is going to be in inches. So when I find x is in units, is inches, and here's your picture, and your variable is x. Now, anytime you're looking at volume, by the way, of a box, it's length times width times height. The length is x, the width is x. It's the area of the base times the height, which is 4. So that's where they came up with the fact that the volume that the guy you're going to be working with is 4x squared. So it's the area of the base times height. It's like the volume of this room is the area of the floor. So it's length times width times the height. So that would be your volume of any rectangular object. And a square is a rectangle, a special case. So it says, if the volume is 269 cubic inches. Now you're going to say, well, why is it cubic inches? Because if I look at length times width times height, it's x inches times x inches times 4 inches. It's going to be 4x squared inches cubed. That's where the inches cubed comes from. It's inch times inch times inch. Volume is always cubic inches. It's like when you order cement, you order per cubic yard. So they're looking at a volume. So they're going to be looking at length times width times thickness in terms of when they give you your cement. So that says that the volume is 289, or that 4x squared equals 289. Get x squared by itself, 289 divided by 4, and that's where I then take my handy dandy little calculator and get out of the graphing mode. 289 divided 4, and that's 72.25. Now what do I need to do? Square root both sides. Don't forget the plus or minus. So that x is plus or minus the square root of 72.25. So square root 72.25 is 8.5. What? Inches.
Yeah, but put cubic on there.
Don't have to put the cubic on there because remember, this unit, that's inch. This is inch. And then this is inch. And then inch times inch is cubic inch. So, however, what is my answer really? Can I have a minus 8.5? No. So it's only 8.5 inches. And the reason for that is length is never. Wouldn't we like it, huh? Negative. Now that's why when I ask the question, are there two possible answers? Is there two possible answers? No. Why not? Because length is not negative. At least not in our system, it's not.